Okay, in this video we're going to discuss integration again. This time we might say, or somebody might ask the question, why do we even need integration? What is the point of integration? Well, one of the things we considered in the last one was that if we take the integral of the derivative, what we end up with is the actual function itself. So if we integrate the derivative, we get back to the original. Well, notice what's going on in this question we have here. If the derivative of f of x equals this function, and we have f of 1 equals 2, find the function at point 2. That means we have to find this guy, and they give us this guy. So let's see, how are we going to do this? Well, we're going to take the integral of the derivative, and the derivative is right here. So in here, we're going to put 3x squared minus 2x plus 1 dx. And we're going to evaluate what is this derivative. Well, we're going to have x to the third over 3 with a 3 in front, minus x squared, that's x to the first, so it's going to become x squared over 2 with a 2 in front, and plus 1x to the first over 1, I'm not going to write that, plus c. We must not forget that. Okay, so what is this purple thing? Well, it is the integral of the derivative, which means we can say this guy is f of x. So we have come up with the actual function now, but we don't know c. Well, that's where this piece of information comes in. This is called the initial condition. So we're going to take f of 1 and just do what you would normally do with f of 1. This means x, the value of x is 1. So I should have canceled some things here. Let's cancel those 2's and the 3's. That means we have x to the third. So, you know what, let's just write that here. Let's just do f of x is x to the third minus x squared plus x plus c. Now what we'll do down here is we'll actually calculate f of 1 down here. So this will be 1 to the third minus 1 squared plus 1 plus c. Well, okay, now if we come back up here, f of 1 is equal to 2. So what am I going to do right here? I'm going to make this piece equal to 2. So what will that give me then? 2 equals, now let's simplify, 1 minus 1 plus 1 plus c. Well, that's going to be 2 equals, that's 0, 1 plus c. So we can say here that 1 is equal to c. Well, now what I'm going to do is I'm going to come back up to this yellow one, and I'm going to put c in there. So we can come up here and we can say f of x is equal to x to the third minus x squared, I'm looking right here, plus x, and then it says plus c here, but we just found out that c is equal to 1. So if I put in here, I put plus 1. So now we have this red one, which is the function of x. So remember, this is one function, and then this other guy is his derivative. Well, what do we need to do with this function of x? Now the question actually says, find the value of f at 2. So now we're going to do something similar, and we're going to put 2 in here. Notice the original reason when we put 1 in here was in order to calculate c, and they had told us that this was 2. Now we're doing the opposite. Now we are given x equals 2, and we're sticking that into our function in order to find out what its actual value is. So what does that mean? F of 2, we're supposed to find out what this equals. This is 8 minus 4 plus 2 plus 1. So 8 minus 4 is 4, plus 2 is 6, plus 1 is 7. So f of 2's value is 7. Something that might be helpful for us to consider, just as a side note here, if it helps you, recognize that this 2, 7, f of 2 at 7 is actually the same as saying we have an ordered pair 2, 7. And if it helps you to think of this piece, this is actually just an ordered pair of 1, 2. Those are the x's and the y's. All right, well, let's take a look at another one here. In this one, we are given the derivative at f of 1 equals 1, and we're supposed to find f of x. So we're going to do something similar here. In this particular one, we're going to start with the integral of the derivative, and this will produce, let's just write it this way, f of x is equal to the integral of the derivative. So we're going to write down the derivative, which is x squared minus 3x minus, now let's do something here. We can't integrate that the way he is, so let's just rewrite him from the beginning. Minus 2x to the negative 2, and then we'll put the dx here, which says we're doing it in terms of x. Okay, so that means we're going to have f of x equals, now we need to integrate this, that's going to be x to the third with a 1 over 3 in front, we divided by 3, minus this is going to be 3x squared divided by 2, minus 2x to the, this minus 2 increased by 1 becomes minus 1 divided by negative 1 plus c. So let's find out what's, well, let's rewrite this a little bit nicer. F of x is 1/3 x to the third minus 3 over 2 x squared. Now this minus and that minus are going to become plus, and I'm going to put this back down in the bottom. X to the minus 1 is going to go to the bottom, so that becomes the plus, and then I have 2, which stays in the top, over x plus c. At this point, we have found the function, but we don't know what the actual value of c is, and that's where this piece will come into play. So now we'll stick 1 in the place of 1 of all the x's, and that's going to, if we stick a 1 in there, it's going to be 1/3 1 to the third minus 3 over 2 1 squared plus 2 over 1 plus c. So this side over here will become 1/3. This will become 3 over 2 plus 2 plus c. Now I left this piece empty because what does f of 1 equal? F of 1 equals 1, so we're going to put a 1 right there. Now with a little bit of simplifying here, looks like a common denominator for these two would be multiply top and bottom by 2, multiply top and bottom by 3. That's going to give me 1 equals 2/6 minus 9/6 plus 2 plus c. Come up here now. This is going to give me 1 equals minus 7/6 plus 2. Now it says plus 2, but I'm not going to write that as 2. I'm going to write that as 12 over 6. This could also be done on your calculator. Plus c. So then, if we add the 7/6 and the 12/6, we're going to get 1 equals, let's change colors. 1 equals, this will be 5/6 plus c. That will tell us that c is equal to 1. If I move the 5/6 over there, c is equal to 1/6. So now the question said, what is f of x? By the way, you could have said, somebody could argue, well look, I've got f of x right here. Why didn't I just stop in this green one here? Well, because they want to know what f of x is without a c value, but rather with this 1/6 plugged in. So, final answer will be f of x is going to equal, now we look here, and we just stick the c value in. 1/3 x to the third minus 3 over 2 x squared 2 over x. Let me comment something. That x is not in the bottom. That x is not in the bottom. That x is in the bottom. Plus 1/6. So that's the answer that we're looking for. Okay, well, let's go with one more here. This one now is kind of interesting. We have here the second derivative. Well, what we could say here from the beginning is we could say if f of x is equal to the integral of the derivative, well, okay, so f of x is equal to the integral of the derivative. What if we had the integral of the second derivative? That's going to equal the first derivative. So this is how we're going to begin with this problem. We're going to start by finding the first derivative. The first derivative is going to be the integral of the second derivative. So that means I'm just going to put a 2 right there, dx. Well, if I integrate that guy, that means I'm going to have the first derivative is equal to 2x plus c. Remembering there's an x to the 0 right in there. So first derivative is 2x plus c. Now they've given me some information here about the first derivative. They tell me the first derivative at the point 2 is supposed to equal to 10. So if I put a 2 in there, this 2 goes in there. This is supposed to equal to 10. So I'm going to take out that and put in 10. So 10 equals 4 plus c. That means c has to equal 6. So now what I'm going to do to keep myself a little bit organized, I'm going to come up here and I'm going to say the first derivative is equal to 2x plus c. Not c, 2x plus 6. First derivative, 2x plus 6. Well, now, continuing this problem is the same as continuing the problems we did at the beginning. Now if we want to find f of x, we are going to integrate the derivative. So integrating the derivative is going to be 2x plus 6 dx. What is that going to do for us? That's going to tell us that f of x is equal to, so this is a first, so it's going to be 2x squared over 2 plus 6x to the first over 1 plus c. Make that look a little bit nicer, and we're going to have f of x equals x squared plus 6x plus c. And now we need to find out, we need to use this. This is our initial condition for the regular function. Do the same thing that we did over here. We take f of 0. So f of 0 is going to equal, now we put in 0, 0 squared plus 6 times 0 plus c, and that is supposed to equal to 9. All of that is supposed to equal to 9. So that leaves us with 9 equals 0 plus 0 equals c. So then, how do we write our final answer? It says, what is f of x? F of x is this green guy with a 9 stuck in right there. So we'll write it down here. Having a little pen trouble here. F of x is equal to x squared plus 6x plus 9. Now, something I challenge you to do if you wanted to get a little extra practice is check that all of this is correct. Take the derivative of that, and you'll get this. Take the derivative of that, and you'll get this.